Alright, this is Geometry A, and we're going to be talking about patterns and inductive reasoning. Okay, so basically, like I've done with all of these so far, is we have a lot of definitions that we have to go over because geometry is huge into definitions. Okay, so we have conjecture, counterexample, and inductive reasoning is what we'll be talking about. Okay, a conjecture is a statement about a pattern. Okay, so it's just a statement about a pattern, pretty easy just to work with. So if I see a number sequence like 1, 5, 9, 13, 17, I would say that the conjecture is I'm starting at 1 and I'm always increasing by 4. So that would be my conjecture. Okay, now counterexample ties in because if I do a counterexample of a statement, I would just say something that proves my statement wrong. So let's say somewhere down the road in that sequence of numbers, okay, so let's list them out. Okay, so 1, 5, 9, 13, 17, and then all of a sudden, boom, 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 I get down the road and let's say I get to 23. Okay, well, no matter how I do the sequence, there's no way I could arrive to 23 if I'm always adding by 4. Okay, so you would say, oh wait, what about this one roadblock, this one number that does not fit that model? So then I would have to say my conjecture is wrong and I have to come up with a different one. Okay, now inductive reasoning is the idea of taking a look at patterns and going with what the next, what the rest of the pattern is going to be doing. And so some kind of pattern that looks like this, obviously we would have, we would say, oh, this is pretty solid, this is going to work for all numbers, and it's going to go all that way. And let's pretend that this counterexample doesn't exist, and it doesn't because I just made it up just to have it happen. But an inductive reasoning would just be a pattern just based upon this, and I could come up with future numbers based upon that. Okay, so please understand that when you guys are using this stuff, inductive reasoning is a huge tool that you can use for your own advantage. And it's huge in geometry because you can make predictions about future sequences or patterns or whatever you want to think of. Okay, but conjecture is just a statement. Counterexample is a negation, and you'll hear me say that a lot during this unit. It's a negation of that conjecture. Okay, and just if you just think about it, it will make sense and it will just work out. Okay, and one famous one that does pop up, if x squared equals 9, then x equals 3. And most people would say, oh, that is a true statement because I can square that. But a counterexample would say, what if x equals -3? Okay, and if you think about that, if I square -3, I get 9 as well. So therefore, this statement, this conjecture, is false because of this counterexample. Okay, so that's huge that you guys pay attention to the fact. The little rules that pop up in math, they are very important to use. Okay. All right. Thank you guys very much and have a great day.